Now we'll think a bit about welded connections. Another day we talked about bolted connections. And in another class, machine elements, we talk about welded joints and weld symbols and so on and so forth, especially in manufacturing. Here we'll think more about structural welding, like in structural steel buildings. And so for structural steel, AISC, American Institute of Steel Construction, has a standard where they talk about welded connections, and in that standard they incorporate an AWS standard by reference. AWS is the American Welding Society, and they write standards for all things related to welds: weld quality, certification of welders, how to make weld symbols on drawings. There are various welding processes, but in structural steel we use arc welding, and as you know, if an electric arc jumps between one piece of metal and another piece of metal, makes a big bright flame and it's real hot, and so that's the basis of arc welding. We can use welding rods, sticks, or we can use wire. Now, the type of weld is really talking about the shape of weld. And so we look at, okay, what do the connections look like? If you've got a corner of some sort, you are probably using a fillet weld. If you have two pieces of material butted together, you are looking at some kind of groove weld. And if you're lapping one kind of liner over the top of another and you're welding through a hole, you're looking at a plug weld. Here's the fillet weld. The shape of the weld material, when you melt the weld material and weld these two pieces together, the shape of the material is basically triangular in cross-section, and so the symbol, which represents a fillet weld, is a triangle. A groove weld, as we mentioned, has two pieces of metal butted together, and it's called a groove weld because usually there's some kind of preparation of the edge, machining off a V, machining off a bevel, gouging out a U shape, that makes a groove, and then that groove gets filled with weld material. So this is a stronger weld, but it's also more expensive, and it involves more labor doing the preparation of the groove surfaces. When we think about stresses on welds, a groove weld tends to experience tension and compression. A fillet weld tends to experience shear, pulling apart that direction. Now, all of them can go in all directions, but this is what we more commonly where we more commonly look at weld failure if it's going to fail. And then here's plug welds again. Basically a fillet weld around the inside of a hole. Here is AISC talking about plug welds used to connect two pieces of metal. Let's think about some guidelines for weld size. While we're looking at this picture in New York City, I just want to point out these beautiful weld beads. This is truly a professional welder who did this work. And you notice that these welds are so big that they made these welds in multiple passes. These are just beautiful. So when we specify the welds, they're in 16th inch increments. It's common to have something around a 1/4 inch weld size, which means if you're doing a fillet weld, that's the base of the triangle. AISC has some standards about that. Basic idea is for a fillet weld, welded on one side, make the weld the thickness of the thinnest plate. So if the thin one were a 1/4 inch plate, this would be a 1/4 inch weld. We don't want to get too big on the welds, so the weld is typically the thickness of the thinnest plate or even a 1/16 less. if you're specifying welds, if you're working for a company, you will ask your supervisor or your engineer, what should I do? What kind of weld do you want here? But just to give us some overview of the deal, if you're thinking about how to keep the cost of welding economical, well, there are several factors. One is labor. A flat weld is lower cost to do than an overhead weld, for example. You want to think about how can we minimize the amount of weld material we're using. Maybe if we're doing a groove weld, it's better to come in from each side rather than to do just a full penetration from one side. And then with a groove weld, if you have a bevel weld or a V weld, these are all V welds here, someone can use a torch and cut that groove with a flame. That's a lot less expensive than a curvy groove called a J or a U. I want to throw this in here, this idea of 3 interrelated factors. These apply to weld quality. You can have a high quality weld, but it might cost more money and it might take more time. You can have a real low cost weld and it would go fast, but you might sacrifice quality, and so on and so forth. Basic idea is there are 3 factors. You can optimize any 2 of them. You can't have all 3. It's like in the old days there was I heard of an auto mechanic shop who had a sign taped up on the wall. You've probably seen these around. The sign said, "You can have it done good, fast, or cheap. Pick any 2." And that's the basic idea here with weld quality and cost. All right, moving on. Electrodes are the stick or the wire that the welder melts into this weld joint. And these are specified by ultimate tensile strength. And you'll recognize these numbers. These are 1000 psi. So if it has a 70 in the front, it has an ultimate tensile stress of 70,000 psi. The third digit here is for what weld position does it require. And if you are doing flat or overhead or up and down or anything, you can have a 1 there. And then the third number is the coating. Just want to point out that when you put weld material in some pieces of metal that you're welding together, the base metal, the weld is stronger than the base metal. And by the way, do you remember that picture of the tanker ship in the previous lecture, the tanker that split in half before it ever sailed? Part of the crack propagation there, among other things, was caused by the fact that the welds were real strong, but the base metal around the welds cracked. So it's the base metal that controls how much the allowable stress is. As we mentioned before, the flat welding position is the most economical, and the all welders can do flat welding. Not all welders can do overhead welding. Finally, last 2 slides, thinking about the difference between shop welding and field welding. So shop welding is, as the name implies, you're in the shop and you weld a thing there. Field welding is where you take the pieces of steel out to the job site, out in the field, and you weld them there. And I don't know if you can see from this picture here, but this is a person up on this orange colored lift here. And that bright colored light there in the corner is the welding arc from their welder. They are welding a connection here. And this is the the stadium, the new stadium at Hayward Field in Eugene, Oregon. What is common is for the steel fabricator, the shop, to do some things to make it easier for the assembler out in the fabricator out in the field to do their job. So in the shop, if there's going to be a groove weld, the fabricator will prepare the edges for the groove. They'll bevel them or V them or whatever. And out in the field, these angle clips will be held on by lower strength common bolts to hold them in place while they're doing the welding. The shop will provide the bolt holes for holding that on, and in many times they'll attach the angle clip to the end of the beam and it'll ship together as one piece. Earlier we looked at how the triangle was the symbol for a fillet weld. So here is a complete weld symbol. In the tail is information about the strength of the electrode. It's got a 70,000 psi ultimate tensile strength, for example. It's going to be a 3/8 weld, that is 5 inches long. And this flag here is the symbol for field weld. So this symbol would be put on a drawing, and this says, here's the size of weld to make out there, using what kind of rod, and do it out in the field. That's what that symbol means.